Welcome back. In this lesson we're going to look at some NPC logic. So of course let's get into our analysis phase. So you can see these NPCs are very simple. They are just walking on a set path. If I come close, they stop to look at me, rotate around, see what happens if I walk away. He goes back to his path. So I would say this is he's patrolling at the moment. Now if I get close, he goes in idle. But there's more than that in this game. If we actually go into the Cookie Mart, we can see a poo, and it's kind of the same logic as that NPC. When I got close to him, he stops and then he rotates towards you. But as we can see, a poo's not in a patrol state. He's not walking back and forth, he's just stationary. So we'll call that idle. So in this lesson, what we're going to do is we're going to set up the framework for our NPC, and we're going to create our first state, which is the patrol state. And yeah, we'll have more lessons in the future that will cover different NPC logic, but for now, we'll stick with this patrol state. Okay, let's jump to Unity. Okay, so how we're going to handle the NPC logic is through a thing called a state machine. So basically, we break the logic up into states, so we're not running code we don't need to run within a single frame. So let's say that the NPC is idle and we don't want it to rotate, then our idle state will not have the code for that. Whereas our patrol state might actually have different code running. So we're only running one set of code at once. It's kind of complicated now, but as I progress, hopefully it'll become more understandable. So the first thing in our scripts folder, we're going to create a new folder called NPC. Let's enter this folder, and then the first script. This is going to be the actual state that all other states will be derived from. So let's say non-playable character state. So this script will never actually be attached to an object itself. It'll only be used as a template for other classes to derive from. So because of that, first thing we're going to do is make this abstract. And then we're going to add some methods. So all these methods we add here now will have to be implemented within any class that inherits from this class. So let's create a method for initializing the state. So public abstract void state init, and we just close that off. No logic in this. This is just a skeleton framework. We'll add the logic later when we create a class that actually inherits this. And then we're going to create another one. Let's say public abstract void enter state. So once the state is entered, this will always be called. Next one, public abstract void exit state. It's kind of obvious, same thing, where we have some conditions that once we exit this state, we might want to reset some values or change some things. So we want to have both of these. We also want to have a update state. So public abstract void update state. And actually we're going to change the wording of this because all the rest of these had state after the word. So let's just rename this to init state. And then we'll also need one more for changing the state. So maybe after some conditions, we will exit a different state. So let's say that your character is patrolling, walking up and down. Well, if your character gets damaged, maybe the player punches them or kicks them or gets hit by a car or something, we want to exit to a different state, a damaged state or whatever. So we'll have public abstract void change state. And that'll do for now. We'll come back to the script later, but this will do. Let's remove these extra things we don't need. And now to hopefully make this a lot more understandable, we'll create our NPC controller. So new C# script, non-playable character controller. You could just do NPC controller, but I don't really like doing abbreviations or all capital letters before I write another word. It'd be different if it came later in the string, but that's why I like writing out non-playable character instead of NPC. It just looks nicer. So our non-playable character controller, we're going to remove all this as usual. And then the first thing we're going to do is create a dictionary. And of course, dictionary works with key value pairs. So our key will be the name of the state, and then our value will be the state itself. So for a key, we could use a string, and then, if the string was idle, then let's return the idle state, and then we run a logic for that. I don't think I'm going to use strings though. I think I'll use enums instead. So let's go public enum NPC states, and then, for example, we'll have idle state, we'll have patrol, none, and we can add to this later, but these will do for now. And then in our dictionary for the key, we'll just add NPC state as a key, and then non-playable character state will be the actual value. Let's just call this state, and then of course we need to initialize this dictionary. So go new dictionary NPC states, non-playable character state. We're also going to want to set a default state. So let's just make it serializable so we can set it for the inspector, and make this NPC states, and then default state. And then we want to capture the current state as well. So NPC states, current state. Now, start. Obviously, we can make our current state equal to our default state, but we need to create a method now to actually collect these states. So let's call it void get attached states, and we're going to get an array, non-playable character state, all states we'll call it, and then we're going to get components. So this is just for a single component. We add an S to this, not in children, we can just do it here like this, and that will return an array of non-playable character states. We could add some debugging here if we want. So maybe if all states.length is equal to 0, let's just do debug.log error. Let's say no states attached, and we'll return. Now, if there is states attached, let's go through them all. So for each, of course, this will be non-playable character state, rename to state in all states. So now all we need to do is add it to the dictionary. So states dot add. So now we actually need a way of setting this non-playable character state. So let's go back to our state class, and then we'll have a public abstract. Now we need to get this enum from our non-playable character controller. So let's try that, non-playable character controller .npc states. There we go. And then we'll call this state key. So we can just remove the abstract from this. I see now we're missing the semicolon here. Must have changed that by accident. So now that we're here, we have the state key, and also our change state. We want that to actually return one of these enums. So let's do that. Change that from void to return this. And now let's save that. Go back to our NPC controller, and now our state will have a state key, and then the state itself will be the value. And we should also just initialize the state when we're in this step here at the start. So we'll go state dot init state. Great. Now we can just call this within our start function, and that should work just fine. In our update, let's just create that update. We're going to have to call our state, of course, our state update. So state, let's get our current state or get the state from our dictionary, so states, and then our key will be the current state. Maybe I'll just rename this actually to make it clear. Current state key. The current state will actually be the state we retrieve with this key. And then we can just do state update, or update state, I believe we call it. Yep. And this is how it's going to work. Hope this is making more sense now. We have our initialize state, we added the dictionary, and our update, of course, we're going to update our current state. What we could also do on our start, we can do state current state, since it's already been set as our default, and then we can go enter state. And I'll cover that too. Now let's check if our state changes. Let's create a new method. Void check for state change. Now let's capture our next state. So NPC states next state equals state current state key. Now change state. So this will return our state key as we set. Now, if this is, if it's going to be none, so if next state, we need to rename this, forgot a T. If this equals NPC states dot none, then we can just return. And then if it's not, then we can go update current state. And this is a new method we're going to add right now. So void that. So to update our current state, we're going to need take in the next state. So NPC states next state, and we're simply just going to exit our current state. So states current state key dot exit state. Then we're going to make our current state equal to the next state, and then we're going to enter that. So state current state enter state, and here let's put in our next state. Great. Now we can just add this to our update, and I'll check for state changes. Now let's actually create our first state, which in this lesson is going to be the patrol state. So let's go back to our project. Let's go create folder state. Enter, create C# script. Patrol state. Of course we spelled it wrong as always, so let's just rename this. And then this, instead of deriving from mono behavior, it's actually going to derive from our non-playable character state. You'll see now this red line. So what that means is we are deriving from this class, but we haven't implemented the method yet. So let's just remove this, go here, right click, quick actions and refactorings, and then implement abstract class. And now we have all our methods that we need to put our own logic in. So first thing we're going to do is on enter state, we're going to set our state key to equal non-playable character NPC states dot patrol. Obviously, if this was idle, we can do an idle. We can actually change this to our init state. And let's just change the order to, they kind of imported in the wrong order here. So not wrong, it'll still work, but it's nicer to have our initialize state first, and then we'll have our enter state, then our update, and then we'll leave our change state there, and exit state will be the last. Great. So actually we're going to default this as well for change state, and let's just return non-playable character NPC states dot none. Great. So let's actually get into some logic now here. So for a patrol state, we're going to want the NPC to walk back and forth between set points, set waypoints. So let's just serialize field so we can edit it in the inspector. It's going to be transform, it's going to be an array of transforms. We'll call those waypoints. We're going to have a current waypoint. So transform current waypoint. We don't need to see that in the inspector, so we'll just leave that the way it is. And we're also going to need a waypoint counter to know the current waypoint we're going towards. So waypoint counter should be an integer. We're also probably going to want a minimum distance from the target before we stop walking. So let's add that. Serialize field. Let's make this a float, and then minimum, or just min distance from target. Okay, so let's go to our update method now here, our update state method. Let's write some logic. So let's capture the distance between our NPC and the current waypoint. So float distance from target equals vector3 dot distance. Now we could do m transform here since the script will be attached to the NPC, but there's going to be some other variables and logic, well, just variables that we're going to need that are attached to the NPC itself. So let's just comment this out for now, but essentially in here we're going to need our NPC's data, and then we want to find the position, let's say, and then our distance going to be between our NPC's current position and then the current waypoint. Now, where we're going to do this is we're going to go back to our non-playable character controller. We're going to create a new class within this. And the reason we're not writing it in the zone script is just because it's linked to this so much that I think it's nicer to have it in one script. So below this class, at the very end of the script, we're going to create a new class. Public. We're going to call this non-playable character core. It's going to be public class, and this is essentially, it's going to be a data container. We're going to hold in here our transform, the nav mesh agent, the forward movement, our values for other things, move speed. So I think this is a clean way of doing it, and we can just feed this into all of the state methods, or most of them anyway. So let's think about what we need. Of course, we're always going to need our m transform. So public transform m transform. We're going to need our animator. Public animator. A lot of similar stuff to what our player uses. Now, to handle physics, on our player we used a character controller component. But with our NPC, we're actually going to use a rigid body. So public rigid body, yeah, RB is a good name. We're also going to use a nav mesh agent. That's what we're going to use to actually control the NPC to walk around. So nav mesh agent. Well, it's called agent. And we're also going to capture the forward amount. This will be for the animations. We might add more stuff to this later, but for this lesson, this will be enough. I think a lot of the concepts are already difficult enough, so let's keep it simple. And then let's make a constructor for this, where we can populate all these values. So non-playable character, core, and we're going to need the M transform, and then we can get all the rest of the data from that. And of course, this on M transform is going to equal M transform. We can get our animator from this. So animator equals M transform get components. So change this to get component and children. Our rigid body will be on the game object itself. So we need to do M transform get component rigid body, and same for the agent. Perfect. And we'll set the forward amount through our actual state script, because this is something that's going to actually change between states. Obviously, if you're idle, that forward amount will be 0, but if you're walking, it could be 0.5. If you're running, it could be 1. So we'll leave this the way it is at 0 for now. And now if we go back to our non-playable character state, our update state, let's just add that. So non-playable character core, we expect that as a parameter. And then if we go back to our patrol state, we have a red line here because we're not asking for that. So let's do that. And then if we go back to our controller, it's going to give us an error too. So we actually need to create a core now. So non-playable character core, and then we'll say core equals new core, and we'll put in our M transform. So it's going to be transform. Let's also just move this above our enter state, just in case our enter state relies on some of the variables held within that core. It's really just a data container we're using. It's like a JSON object, but with all these fancy Unity classes. And of course, in our update, let's just put the core in, and we should be good to go for now. Let's go back to our patrol state. No errors. Let's uncomment this, and now let's change this to core, and let's change this to M transform dot position. This will be current waypoint dot position. Now this variable will be distance between both of them, and of course, if the distance from target is less than or equal to the minimum distance, so that just means that you've arrived at the target, then we want our waypoint counter to go up. So we want them to move to the next waypoint. And then if the this is some checks that if the waypoint counter is greater than the waypoints dot length -1, of course, then we want the waypoint counter just to go back to 0. Of course, we'll set the current waypoint to the next one. So waypoint counter. Now this is the great thing about having a nav mesh agent. We don't need to write any logic for movement or rotation. That's all handled by the nav mesh agent. All we need to do is say core dot agent, and then we just set the destination as our current waypoint. right waypoint dot position. Great. Now we're almost on to a point where we can test this. A couple things we want to check first. Not every state will use the nav mesh agent. So let's just say core.enable. So we need to actually bring our core into here as well. So let's just copy this, go back to our state, our enter state. We're going to bring the core in as well. Bring it there. And then in our enter state here, we'll give in the core. And then core.agent.enabled equals true. Because we definitely want that to be true. We also want to set our current waypoint. So we'll just set it to the first value of our waypoint array. So current waypoint equals null. Then we'll just say current waypoint equals waypoint, oh not waypoint counter, waypoint 0 position. And of course we'll just set our destination to our current waypoint, same as we're doing here. And we can also change our exit state to disable the nav mesh agent. Core.agent. Oh, we need to, of course, feed it in here too. Copy, paste in there. Core.agent.enabled equals false. Save controller. Obviously, we're going to get some errors here. We just bring in the core. Okay, so now I think we're in a good spot. I think we can actually start setting some stuff up and testing some of our logic. So let's go back to the project. Let's go to our polygonal starter prefab characters folder. Let's pick the female character, drag and drop in the scene. Let's just bring her a little bit forward, in front of our character. Let's also change the material. I accidentally changed it to 2D there. Let's change the material so she looks a bit different. Okay, so that's the blue one. There we go, yellow. Looks like Marge. We'll do the same thing that we did with our player. So let's go prefab, unpack completely. We'll change the name of this to model. And then we will create an empty parent and we'll say NPC. Let's just disable apply root motion. We're going to use the same animator controller as our player. Use the same all animation. So we can actually rename this animator controller to something like human. We can do that later. RPC is going to, of course, use our NPC controller script. The default state will be patrol. We also want to add our patrol state. The state key is going to be idle. So maybe, yeah, we don't want to be able to change this here. Patrol state will always have to be idle as a state key. So let's go back to our code, go back to non-playable character state, and then here, we still want to keep this public because we only read and write to this variable. So to hide it from the inspector, we'll just simply add this tag, hide inspector. Go back to our game, it should disappear. There we go. Minimum distance from target, let's say that's something very low, maybe 1.5f. And then waypoints, we'll create those in a second. So if you remember back to the stuff we have in our player controller core, so we have transform that's automatically there, animator is in the child, rigid body, we need to add that, and then nav mesh agent, we also need to add. So rigid body, of course for the rigid body we're going to need a collider, so let's add a capsule collider, and bring it up a bit higher. Let's increase the height to 2 maybe. And we'll set it to 1 on the Y position. I think 2 actually might be a bit too much. Or we'll change the radius actually. Yeah, maybe 0.25. On a rigid body, we want to constrain the position on the Y. And unless we want to do some jumping later, we can disable that, but I don't think the NPCs actually jump at all, so leave that as frozen. And then rotation, we only want to rotate on the Y, so let's freeze the X and the Z. And of course we also need our nav mesh agent. Now by default, that's not installed in Unity, so we go Windows, Package Manager, Unity Registry. Let's type in AI Navigation is the package we want. Let's install that. Now that's installed, let's close this down, go back to your NPC, and now let's add a nav mesh agent. There we go. So you can see we have this new cylinder around our NPC. Now let's look at some of the settings here. We've got speed, we'll change that once we start testing it. Angular speed, acceleration, stopping distance 0, auto braking. We actually turn that off because we're going to handle that through code ourselves. I think everything else is fine here at the moment. Now for a nav mesh agent to work, we need to bake a navigation mesh. Basically the saying where is walkable. So let's go to our hierarchy, right click, AI, nav mesh surface. And if we click, let's just reset this to 0 and then bake. All this blue area is where they can walk. Now you see this white area that's not being touched. That's because it is viewing the NPC as a static object. So it could, it could be a wall or something you don't want your NPC to walk near. But obviously this is the NPC itself, so we want to fix that. It'll be the same with our player. Yeah, we have this area here that the NPC shouldn't walk near, and that's because this nav mesh surface just sees these as static objects and not dynamic moving things. So what we can do to fix that is add them to their own layers. So let's go player first. Player is actually already on player layer. We already did that. So let's go NPC, add layer, NPC, and then go back, NPC. Yes, change children. Now if we go back to our nav mesh surface, we should have or include layers. Let's remove our NPC and our player. And if we bake again, we see that's fixed. Great. Now we're almost there. We just need to add some waypoints now. So let's create empty. We'll say waypoints. Remove this, reset position, and then create empty waypoint 0, and let's just make that maybe up here, a little bit ahead of our NPC, and then Control D, and let's make a new one, rename this to 1. Let's bring this waypoint over here, and we'll just do 2 for now for testing purposes. Now if you go back to our NPC, we have our list of waypoints. We 2 for now. We add our first one and our second one. Okay, so will this work first time? Let's see. We did a lot of coding without testing, so let's see how this goes. I expect some error. Nope. Seems to be working perfectly, and it goes back and then back, so it keeps going back and forth between these 2 waypoints. That looks good. Now let's just add a third waypoint. Control D, let's bring this further so it's be a triangle now that she's walking in. Go back to NPC, add a waypoint, it's gonna be the third one, and this should actually be renamed to 2 since we're starting at 0. Press play. So our current waypoint we set to the first one. She walks there, over there. Great. Now of course she's not animating at the moment, which is easy enough to fix. We'll go back to our code. In our patrol state, when we enter the state, we'll want the core, not const, core dot forward amount to equal 0.5, because if you remember, our animation walks at 0.5. And then when we leave, well, we could, let's just default to 0 when it leaves, but usually the next state will handle the forward amount itself in its own way. But let's just add this just in case we forget. Now if we go to our NPC controller, we're going to create a new method for handling animations. So public void handle animations. We're going to take in our delta, and this will actually just be the exact same method we use in our player controller. Let's go down, yep, handle animations. Let's just copy and paste this in. Perfect. So we're going to add our core as well. Oh wait, the core is part of the script. We don't need to add it as a parameter. We can just call it from here. So core dot, and then core dot, it's going to be forward amount instead of move amount. Now let's just call this within our update. We're going to need to add the delta, so let's add it at the top. Float delta equals time.delta time. Leave that as that. Semicolon. Done. Let's go back to our game. Press play. And there we go. She walks, she rotates. Maybe she's walking a bit too fast. So if we go down to our nav mesh agent, let's change the speed to 1. See what that looks like. How do we feel? Feels a bit too slow. Let's go 1.5. Yep, that looks better. The rotation's a bit slow. We don't have rotation animations, but I think if we rotate it quick enough, it'll look more natural. So let's change this from 120 to, let's say, 240 for the angular speed. Yeah, it's looking better already. I think we can actually push it even more. Let's change this to 360. Yep, that looks a lot better. And that's it. We have a simple patrol state going. The main part of this lesson will be set up this somewhat complicated structure for our state machine for our NPC, but when we develop more states in the future, it's going to be a lot simpler because we have this hard work done already. Most of our logic within our NPC controller shouldn't be touched anymore now because these are all automated. In the next lesson, we'll look towards something else, just to give us a little bit of a break. And then we'll come back to creating more NPC states in the future once we have more stuff going on within the game. But I think for now, this is a good place to end it. Actually, let's just actually play the game. Let's move our character up. So let's see what happens if we get in her way. Oh, she'll just walk straight around us. She does not care. She turned. I think that breaks her logic. See if there's any quick ways we can fix this before the lesson finishes. So I think we can actually set our NPC as kinematic from now, since we're moving the character with the nav mesh agent and not actually through physics, well, at least not directly. So let's try that again. Let's press play. Let's walk towards her. She's back to walking fast again. We need to reset those values. But let's try to walk in there. Yep, she does not care. She just walks through us. We can't budge her. That's great. And just before we go, let's actually just set these values back. So I think we had them at 1.5 for speed. Angular speed we had as 360. And I think everything else was fine. Now just before the end of the lesson, play maximize. Let's have a look at everything. Great. That looks natural. That looks clean. So of course, if you enjoyed this lesson, make sure you subscribe for more, because there's more coming. And tell me what you'd like to see. If there's something that I'm missing so far, let me know. I'll see if I can cover it. I have a lot of plans already, so maybe what you're going to suggest I already have in the works. I hope you're enjoying this development as much as I am, and I'll see you in the next lesson.